Hello everyone, my name is Yeremia Klesiak Karnomisi and I'm from Informatics 48 International Class, and this is my student ID 1030124400013. Okay, so the first number on the calculus assignment on the section C, the first number is Billy takes 300 milligrams of blood pressure tablets every morning at the same time. So we can just we can assume that Billy is, if on a Monday Billy is taking the blood pressure tablet, and then he will drink the next blood pressure tablet on the Tuesday morning to be exact, and then the drug is decays exponentially in the bloodstream at a constant hourly rate. K is 0.12. So 0.12 is the delay rate, and it is symboled as K. So we got to the question: how many milligrams of the drugs remains in the body 24 hours later, or just before the second dose? How much just before the third dose? Oh, so there's a two question. The first one is after 24 hours, and then the second one is the before the third dose. So after Billy drink the drugs at the second time, and then just nearly before the third dose, and how many doses does it still on his body? Okay, so first thing first, we have to work with this formula. This is the formula. Okay, and then we applied the formula of the A0. What is A? A is the grams of the tablet in the body, on the blood. So the first one, when he takes the tablet, there is 300 milligrams of blood pressure, right? So the dose of the tablet is 300 milligrams, and then after 24 hours, how many grams does it still on the body? It's not 300 still, right? Because there's a decays. The drug will decays exponentially in the bloodstream at the constant hourly rate. So it depends on the hour. For the first hour, it decays by 0.12, and then for the next, it will keep decaying. And the decay formula is this one. So we just input all the things that we've gathered here: the A, delay rate, the formula, and the time, to this formula. So this is the A, or the milligrams of drugs, and then this is the delay rate, the minus. We got minus here because on the formula we got the minus of K, or minus of delay rate, and then times with the time here. The time is an hour. So as we can see here, the exponentially decays rate is 0.12. I put it here, and then 40 hours is 24 hours, so I just times it. This is power, so it's not an exponent, it's the power. So no, it's exponent times the K times by the T. So as we times that, we got minus 2.88. We times that by 300. Oh, the E power of minus 2.88 is equals to this, and then this we times with 300, and then we got this one. So how many milligrams of the drug remain in the body 24 hours later? It is 16.83 milligrams. And how about just before the third dose? It's quite the same. We just have to add this one with 300. Why 300? Because after this, this is like just before he takes the drugs, right? After this, Billy takes the drugs again, and then it adds 300 milligrams more to his body. So 300 we add with this 16.83, and then that would be 16.83 milligrams in his body. There would be this much in his body, and then we can just times this by the formula. The formula is E power minus K times T, right? Then we got is 316.83 times by E power of 0.12 times by, what is the K? 24 hour, right? Yeah. Because after the second hours, he eat this, and then he asks about if this is the remaining grams of drugs in his body, the problem asks after just before the third dose. So Billy have to wait for 24 hours, right? Because he already takes the second dose and he want to take the third dose. So he have to wait 24 hours because he have to eat it every morning and then at the same time. Okay, so next here, we know that e power of 0 minus 0.12 times by 24 is equals to minus 2 comma 0.88, or just similar to, like, close to 0.0561. So we can just change this to 316.83 times by 0.56 sorry 0.056 and 1. Okay, and then the result of this is close to 17.77 milligrams. Okay, I'm using calculator for this because it is too hard to count it by hand and to maximizing my time. So if you count this at the calculator, you will got this. So we've got two answers here. So the first one is after he's taking the first medicine and then he waits 24 hours, then this is the remaining drugs that is still on his body is 16.83. And then after he eat this, he waits 24 hours again. He waits 24 hours, and then just before he drink the third dose, this is the milligrams that it stays in his body. Okay, so that is on number A. So then we have to move to number B. In the long run, how much of the drug remains in the body just before each new dose? So it's just in the long run. So he is taking the pills like as the previous number. He's just taking the pill the first time, and then the second time, and then the third time. For this, he takes it like repeatedly, regularly, like the third, the fourth, the fifth, and how much of the drug remains in his body. So if we count this, we have to make another formula. That is A equals to A plus 300 times by E minus 2.88. I just simplify this because he eats the drug is every 24 hours, right? So I just simplify this one into this one. No, this one, yeah. So here, why is it A plus 300? A is the dose of his body. Like, if Billy drinks a drug just before he takes another drugs, then A is the remains of the milligrams on his body. So if we're talking about on the long run, he, of course, when he takes another drugs, he still has these drugs in his body. Then this is what we want to look, the remaining drugs in his body before he eats another drugs. Okay, let's just count this one, just like normal calculations.